Hey guys, I was just going through my week 4 surveys, which only like half of you guys did. They take just a couple of minutes and they are free points, so please do them. They also count against you if you don't do them. Just, try to next time you have one, just try to log on because again, free points. But anyway, I was going through those, and the biggest issue that I saw was that people had problems with the quiz. And generally, when that many people have problems with a quiz, it's my fault. So I'm going to go through the quiz really quick. We can talk about the answers. And I haven't looked through this yet, and we'll see if there are any mistakes I made or things that I might want to fix or maybe assign some extra credit for. So let's check it out here. Question 1. What do enzymes do? Bind the products of a chemical reaction. Lower or increase the energy required for a chemical reaction to take place. Lower the energy required for a chemical reaction to take place. This is my gut reaction. Increase the energy input into a chemical system. So this is definitely the answer. It's definitely lowering the energy required. I don't know if you guys remember, but in my lecture I had that little diagram where it showed, hey, here's the activation energy without an enzyme. It was really high. You had to put in a whole bunch of energy to go from reactants to products. And then if you had an enzyme involved, it lowered the amount of energy required. It lowers the energy required for a chemical reaction to take place. Okay. Biological catalysts, enzymes. Let's check out the next question. What is the main point of cellular respiration? Turn glucose into cellular energy, creating ATP exclusively for blood cells and occasionally brain cells. Respiration does this, but it's not exclusively for blood or brain cells. Inhalation and exhalation, no. That's the point of maybe regular respiration, but cellular respiration is different. Turn light energy into glucose. That's what we're going to be talking about next week. That's photosynthesis. But the main point of cellular respiration is to turn glucose into cellular energy. What comes out of glycolysis? I see the answer here. 2-pyruvate to... Oh, I see why people had an issue maybe with this one. This was rude of me. Because this is just almost like a multiple, not quite, but this is almost just like the same answer, but more. Yeah, this was not great. This is a fair question, but not a very nice question. Yeah, the answer is 2-pyruvate, 2-NADH, and 2-ATP. This is a bit much. I probably should have put one of these other like bogus answers down here. I will think about this one because, yeah, it is fair, but it is very rude. Okay. What is the point of the electron transport chain? Well, it's to generate a lot of ATP. Use oxygen to accept transported electrons. Yes, this happens at the end, but that's not the point. That's not like your cells aren't doing this so that they can bring in oxygen. They bring in oxygen so that they can do this. So the point of the electron transport chain is to generate a lot of ATP. I could see how folks might have been maybe a little bit confused by this, but this is the answer. The point of the electron transport chain, make as much ATP as possible. Transport electrons to the next phase of cellular respiration. There is no next phase. I guess it is cyclical. It does start over, but no, you're not taking electrons out of the electron transport chain and putting them back. You're taking those electrons and putting them onto oxygen to make a water molecule. None of the answers are correct. Well, no, this one is correct. So the answer is the point of the electron transport chain, generate a lot of ATP. I don't like to know how much time I have. What kind of metabolism is cellular respiration? Hypometabolic, metabolomic, anabolic, or catabolic? Well, it is anabolic. We are building a molecule here, right? We're building a molecule. Where does the citric acid cycle take place? Within the mitochondria. Glycolysis takes place outside of the mitochondria, just in the cell. Then remember, from glycolysis you make 2-pyruvate. Those pyruvate are converted into like that acetyl-CoA thing. It goes into the mitochondria. It spins around in the mitochondria, spins around the Krebs cycle or the citric acid cycle. You get some high energy electron carriers that are sent to the electron transport chain. Anyway, that is a very long-winded way of saying the citric acid cycle. The citric acid cycle takes place within the mitochondria. A mad scientist, this is almost the same question. A mad scientist invents a machine that can totally destroy all mitochondria in a cell. How far will a cell that has been exposed to this machine be able to in cellular respiration? Okay, so this is a poorly worded question. Just from the get-go, obviously, like there's some grammatical errors here. It won't be able to undergo any phase of cellular respiration. Only to the citric acid cycle. Well, citric acid cycle takes place within the mitochondria, so this is not a good answer. Only to glycolysis, that's my gut reaction, because glycolysis takes place outside of the mitochondria. Only to the electron transport chain. Electron transport chain is happening in the mitochondria. So you can't do citric acid cycle, can't do electron transport. You can, however, do glycolysis. Oh, this is the last question. Which of the following follows from the second law of thermodynamics? Energy can never be created. Evolution is impossible. All closed systems in nature are constantly moving toward disorder. Evolution is inevitable. And this is another poorly worded one because this is the second law of thermodynamics. Yeah, it's just saying that everything is moving toward entropy. By the way, the reason that this doesn't make evolution impossible is because we are constantly getting energy from the sun here on Earth. It's kind of like people say, oh, the second law of thermodynamics, it means evolution can't happen. And it's like, well, if you think about it like that, that also means that you would never be able to even make like cookies in your oven because you're decreasing the disorder within that system. Anyway, I'm not going to go off. By the way, so, you know, unless I ask you guys not to, or unless I ask you to use lockdown browser or something like that, this is also kind of an option where you just, we'll just copy this and we'll actually I'll have to type it. Second law of thermodynamics. Total entropy in a system can never decrease over time. Okay, that might not have been a useful one for this one. But we are always increasing the entropy in the universe. Things in the universe are moving toward disorder. So let's submit the quiz. We'll see how we did. Okay. Oh. I messed that one up. Oh no. Okay, well, I have to give you guys extra credit points. So cellular respiration is catabolic. We are breaking things down. Bum, bum, bum. Yeah, I had a brain fart on that one. Yeah, so I'm definitely going to give you guys a couple of extra credit points on this because clearly I didn't even do it right. Yeah, and so like the wording of this is super problematic. Yeah, so yeah, I'll go ahead and give you guys a couple of extra credit points. Hopefully that addressed some of the issues that you had. Yes, cellular respiration, catabolic. We are breaking things down.